that? All right. So already you have the ability to make decisions, and I think that is fantastic. That's wonderful. And if the world was just based on you making simple decisions, you would be fully effective. Fantastic. Unfortunately, that's not actually the way it normally works out, right? There's lots of different sorts of decisions made. There are simple yes or no, but generally there's yes or no. Well, actually, so you guys have been to McDonald's before, right? Yeah. All right. So you have to decide what you're going to have when you go to McDonald's, right? Are you going to have beef or chicken, right? I mean, there's other decisions, but that's the fundamental decision, right? You know, if you decide you're going to have beef, what kind of beef can you have? Really? Anyway, quarter pounders, Big Macs. What else we got? Singles, right? Now, can you get it with cheese? All right. So now we have more decisions on that one. Bacon. That's a good, excellent point. And now, on the chicken side, we can have what? We can have a chicken sandwich. Can we have strips? Can we have nuggets? Yes. We have chicken sort of processed any way we want, right? So clearly, just simply to go to McDonald's and place an order for some delicious and tasty food requires you to make multiple decisions. So maybe that's what we're trying to talk about. Your ability to go to McDonald's. All right. Let's talk about this is a sample if problem, okay? We have a scheduling program. We have people making schedules, making appointments. Let's say they're making dates. We're going to go on a date. So they make a schedule. That's fantastic. No problems with that whatsoever. However, tragedy can occur if they schedule overlapping dates. Right? That's not going to be good for anybody. Okay? So we're going to help them out. We're going to write a Python program that'll check their date schedule and let them know if there's any overlap. Sound like a fair deal? Okay, for simplicity, appointments start at a full hour, and we use military time with hours at 0 through 24. Fantastic. All right, so let's see how this one's going to work. I guess what this is really sort of a refresher if statements for you. So we're going to start here. We're going to say start time number 1 in integer input. And look at this. Actually, I think this is rather clever. I like this new technique, and I'm going to be using it going forward. Remember when I showed you some programs previously, I would get the input, and in Python, inputs come in what format? Strings. And then next line down, I have something that will convert that string to an integer or float or whatever I need. Turns out you can do it all in one line, right? Yeah. So integer, round, whatever. Okay, anyway. Integer of an input, please enter the start time of the first appointment. Same thing for N1 input, enter the end time of the first appointment. We do the exact same thing for 2 other variables, start 2 and N2. So now we've got 4 variables, right? Fantastic, great. Now we have to figure out if there's any sort of overlap between them, right? Okay, so what we're going to do here, we're going to see if start 1, so when the first date starts, if it's starting before start 2, then S equals start 1. One of the interesting things about this program is it doesn't make an assumption that the first date that you enter occurs before the second date, right? So this could be one that's going to happen late in the evening, this one could be the one that happens in the afternoon. The program doesn't make an assumption that you're entering in sequential order. Make sense? Okay. So if start 1 is greater than start 2, then the S equals start 1, otherwise S equals start 2. Okay. So basically S is going to equal the latest possible start. Okay? For N, if N1 is less than N2, then E equals N1, if else E equals N2. So basically E is going to equal the oldest, no, the newest end date. Then we do, if S is less than E, print the appointment overlap, otherwise print the appointments don't overlap. Not a lot of code there. You can see there's an if and an else statement. Okay? Should we run it and see how it goes? All right, when does our first appointment start? 8 o'clock. Okay, and when does it end? 10. 8 to 10 in the morning, right? Because we're in 24 hour time. That is. When's our second one going to start? 13. Yeah, what's 13? And when it's going to end? 14. Do these overlap? No. Answer is? you want to give for something that overlaps, just to give it a shot. All right. So we'll start with your 8, and we'll do your 10. Should we do 9 to 11?
Yeah.
And what should this one do? All right. I like that pretty well. All right. Once again, sort of just showing you the power of the if statement, which you already knew. But we just want to do a little memory refresh there. Okay. Hand tracing. Okay. So when you're working on your homework, hopefully you type it in, you run it, and it works perfectly. Yay! Life is great. Okay. There's always the possibility that won't happen. And the question is, well, what then? Well, at that point in time, you're going to have to knuckle down and figure out what the heck's going on inside of your program that's causing it to not work. Hand tracing is a very classic sort of thing that you can do. So let's take a look at this. Hand tracing is simply a technique that you use to determine if your program is working correctly. More often than not, you use it when it's not working correctly. It's a mentally execute your program statements and keep track of the value of each variable. So what you're going to do is go stepping through your program, scribbling down on a piece of paper what things should be equaling at that point in time. What you're looking for is if there's a problem. Okay? Simple stuff, not terribly hard. Just want to do it once, so we stick it in your head so that you know that this is a tool that you have available to you. So let's talk about taxes, because what could be more interesting than taxes, I said. All right, so if you're not married, and if you're making less than $32,000, then what the government says is give us 10% of everything you've made, okay, on the amount over 0, which basically gives us 10% of everything. Okay, that's cool. If you're single, but you're making a lot of money because you're making more than $32,000, then the government says, hey, right off the bat, write us a check for $3,200, and then give us 25%, excuse me, of everything that you make over that. That's not, it may not be fair, but is that clear? Yeah. All right. We're going to do the same thing for married. If you're married and you're making less than $64,000, just give us 10% of everything that you've made this year. If you're making more than $64,000, give us a check for $6,400 and give us 25% of everything that you've currently made. Okay? Boom, that's it. That's the tax law in a nutshell. We come over here and it's sort of hard to tell, but these are like triangles and these are like brackets. So single, true, false. Okay, true. Is your income less than or equal to $32,000? Then it's just 10%. If it's more, then it's 25%. And here, if you're married and you're making less than $64,000, you're in the 10% bracket. Otherwise, you're in the 25% bracket. Okay, so this is all sort of standard sort of stuff. Okay. Hey, look, here's the code that implements that. Fantastic. Okay, do we really care about the code this time? Not that much, but what do we got here? They're setting up a bunch of variables. Rate 1 is 0.1, rate 2 is 0.25, because those are the two tax rates, right? Rate 1 for a single limit, basically that tip over point when you have to worry about the rate is $32,000. If you're married, the tip over point is $64,000. Remember, that's when you start figuring out the percentages and stuff like that. We read the income and marital status, and we say, so enter your income, how much you make. It's a float, okay? Marital status is single or married. Remember, there's no strangeness going there. We're cool with that being a string, right? It's going to be a little less, or it's going to be a little less. No problems with that. We're going to compute the taxes due. So what they're going to do is they're going to initialize tax 1 to be 0 and tax 2 to be 0. And they're going to initialize it because I think they're going to use it in an expression later on where it needs to have a value when they start. Okay? If marital status equals S, which means you're single, then if income is less than or equal to rate single limit, which was $32,000, meaning less than $32,000, then tax is equal to rate 1, which was 10% times your income. All right? No rocket science going on there. If you're single, but you're making a truckload of money, then rate 1, then tax is going to equal to rate 1 times the single limit. So what is that going to be? So rate 1 could be 10% times rate 1 single limit.
3,200.
Yeah, so what they do is they're calculating the amount of money to the government. So you write them a check for $3,200, and that's what this first one is here, right? And then on tax 2, what they're going to do is they're going to take your income, they're going to subtract off $32,000. So that's all gone. And the remainder part, they're going to take rate 2, which is going to be 25%. All right, we've worked that. But it's taxes, so that's sort of what you expect. By the way, we're going to do exactly the same thing for, if marital status is single, here's an else statement, which means that this is what? You go here when. If you're not single, you must be married, exactly. So the else statement is all about what you do with married. It's the exact same thing as for single, just with different numbers. Total tax is equal to tax 1 plus tax 2. Remember, tax 1 is if it exists. Remember, we initialized it to be 0, so sometimes it's going to have nothing. But if it exists, it's going to be either $3,200 or $6,400, plus the tax in the part that was greater than $32,000 or the part that was greater than $64,000. And then we print it. Boom, we're good to go. Now this is a sample output. Please enter your income. Okay, $80,000. Please enter single for single, M for marital, married, M means they're married, and it came out and said the tax is $104,000. Cool. How'd they get that? That's the question we have. Well, good news. We're going to do some hand tracing over here. So what do we know when we start this? Okay, we know that the income. It would appear as though I've dropped to 0 in income. Let's pretend that that's 80,000. Okay, and it would, and it's an integer. So and then marital status is M, so there's another 0. Oh wait, I can drop it everything, but okay. Cool. So now we go on, and we hit this point here, right? Tax 1 and tax 2 are set to what?
0.
So we come over here with a little pencil.
You draw 0 and you draw 0.
Okay, right? That's the yeah, we put it. This is where I'm going to get all right, so then we move on. Now we're married, so we go down to the else statement, right? Our income is $80,000. So is income less than or equal to rate married limit? Is it less than or equal to $64,000? $80,000. Is it less than or equal to $64,000? No. So we go to the else statement. So tax 1 is going to equal to rate 1, which is 10%, times rate married limit, which is $64,000. So 10% times $64,000 is what? And we're going to place it into which variable? So that goes poof right there. And we're going to calculate tax 2 as being rate 2, which is 25%, times our income, which is $80,000, minus rate married limit, which is $64,000. So 80 minus 64 is going to be what? 16,000? About 16,000? 16,000 times rate 2, which is 25%. So what's a fourth of 16,000? 4,000. So we're going to stick that in tax 2, right? Poof. We're good to go. All right. Using your pencil and a piece of paper, we got this. Okay, cool. And then we're going to go down to total tax, which is tax 1 plus tax 2. So tax 1 plus tax 2 is going to come out to be what?
6,800.
6,000.
Oh wait, no, sorry,
4,000.
3 numbers wrong. I added 4.
I never make mistakes like that. That is 80,000. So let's just go off from that. Okay. It's going to come out to be 10,400. That's not acceptable. So then we'll come over here and scribble that down. And we're good to go, right? So that's effectively hand tracing a program. Okay? And the reason I did it was just to show you. The reason that you might do it is that if you were getting the wrong number, if you were getting 11,000, you're like, 11,000? What's going on with that? Okay? So you go hand tracing through this to figure out what things were at different points in time. By the way, just in case you haven't quite figured this out, in a Python program, can you put a print statement in any place you want? You can drop a print statement in anywhere, right? So I could go in here and I could say, hey, print what tax 1 is at this point in time in the program, right? So if I have things like tax 1 that are starting at one value and going to a new value, I might want to put a print statement in there. Am I going to go back and delete that print statement? Yeah. But I can drop the print statement in any place and that'll just let me know what's going on. What's a nested branch? Interesting question. Nested branch is simply when you have a branch inside of a branch. Basically multiple decisions. Remember, we went to McDonald's. We had to make a decision about beef or chicken. Then once we made that decision, we decided we wanted to have beef. We had to decide between a single or a quarter pounder or a Big Mac. So all of a sudden, it's basically a bunch of decisions stuck together. You have to make a bunch of decisions to make your overall decision. Okay? Often necessary to include an if statement inside of another, such an arrangement is called a nested set of statements. Hey, you're going to go clubbing. Woohoo! We're going out. We're going clubbing. Bam! So we come to the club. Number one question we have is the club full? If it is, go wait in your car. Yay, it's not full anymore. Great, go wait in line. All right. If we reach and the club is not full, then the question is are you important enough to be on the VIP list? If so, go right on in. If not, go get money. Okay? So to get into that club, there are two decisions that are going to have to occur potentially, right? So is it full or are you on the VIP list, right? So that's a nested if statement. Okay, so here's an example of exactly that situation. So this is just coding it up. If people in club is less than max people in club, so in other words, if it's not overcrowded, and if your name is on the VIP list, then you go right in, right? No problem with that. If you're not on the VIP list, then you'll wait in line. And oh, by the way, if there's too many people there, then you're going to end up waiting in your car. But you see how you have two if statements? No problem with that. Notice that these if statements, of course, are all indented. Because why? Why do we indent?
That's not know the word again.
That's exactly right. So go right in, it's like double indented, right? Because it's inside of this if statement. Otherwise, Python gets very, very confused. You don't want that to happen. Multiple alternatives. What should you do when you have make a decision with more than one alternative? Okay, here's an example. Telling a student what their grade in the class was. If you take a class, what are the possible grades you could get?
A, B, C, D, and F.
Okay. All right, so I'm going to tell somebody what the grade is. I got A, B, C, D, and an F. So I got 5 choices, right? How am I going to do that? If your grade is, what, 90 and above, you got a what? An A. Okay. Greater than or equal to 90, you got A. Then what do I have to do? Else, right, for everybody else, you didn't get an A, right? If the score is greater than or equal to an 80, what'd you get? B. Turns it out to 4. That's what I'm asking. Okay, good. All right. Now, if you didn't get an A and you didn't get a B, then we have to go to this else, right? If it's greater than or equal to 70, you got a C. Assuming you do not get an A, a B, or a C, you are in a small pile of tears on the floor, but you go to this else, right? If it's greater than a 60, you got a what? D. And assuming you do not get an A, a B, a C, or a D, we end up in the final else. And there's really no comparisons or something because we know exactly what you got. Apparently you did no work, no effort, and you got exactly what you deserve. All right. So there's some problems with this. So this code is perfect. This is a great code. This is exactly what I've taught you. This is how you would tell a student what they got the grade on. You have to have, how many of these? 1, 2, 3, 4, 4 separate decisions. That's fine. But you see how this indenting is going? It's going to be off the page in about another couple of weeks, right? Okay, so there's some problems with super nesting. First off, it's sort of difficult to read. I mean, it's not entirely clear what's going on there. I mean, you can read it and then you'll get it and stuff like that. The other problem is that you're going to go off the page. You know, give me another couple of these and I'm all the way off the page. Wrap it around at some point, right? So there has to be a better way to do this stuff because we do multiple decisions all the time. Good news. Elif. Okay. This is such a common thing that in Python they came up with a special statement just for this. So if class score is greater than or equal to 90, you got an A. Else if, which is basically just repeating the else statement. Class score is greater than 80, you did okay, you got a B. Else if class score is greater than 70, 60, else poof. Notice it's a much more compact form. We don't have to do all that crazy indenting and all that stuff like that. We're just repeating our ifs using the elif statement. Okay? And of course on this one you have to test the more specific conditions first, right? Did you get a 90? Has to be the very first thing that we test, and then we go down. Because everybody down here did not get a 90, everybody down here did not get a, et cetera, et cetera, et cetera. So, question?
What would happen with the elif if for the 60?
Talk about it right there. This is the second thing.
I believe that would be actually a typo on my part. So pretend like that if isn't there. Does that make sense?
Would register if it was in your account.
It would flag it as an error. It would, we could probably find out. So, Does that look like it'll test it?
Yeah, that'll work.
And we got a 55, security 90, and this is that goofy thing that's there. So we think that's going to get flagged as an error, right? That's my psychic prediction. So let's find out.
How are you doing moving the cursor there?
Pretty handy. That idle is a nice little thing. So basically, what we think is 1, 2, 3. Now if I run it, I should have no problem. Sorry.
They wrote out the correct statement.
All right. Sorry about that. First we have an 80,000 problem. Now we got extra ifs. Okay, but you get the gist of it. An elif is a powerful statement that allows you to make your nested if statements a lot clearer as you go through it. Supermarket coupons. May as well do an example. Okay. Supermarket awards coupons, depending on how much you spend. That's pretty common sort of stuff like that. Spend $50, you get a coupon worth 80% of that amount. The following table shows the percentages used to calculate the coupon awarded for different amounts spent. Write a program that calculates and prints the value of the coupon a person can receive based on the grocery purchase. Here's sample output. Please enter the cost of your groceries, $14. You win a discount coupon of $1.12, 8% of your purchase. All right. So if I spend less than $10, I get nothing. From 10 to 60, I get 8%. 60 to 150, 10%. 150 to 210, 12%. Over $210, I get a coupon for 14%. Cool. I'm going to write this program. So what's the very first thing I have to do in the program? Trick question. Comment would be good. Okay. But what is after the comment? What do I need to do?
Input,
Input. And what am I going to ask them for?
how much they spent.
How much they spent. Fabulous. Cool. They'll come in as a string. We're going to make it what? Probably like an integer. We do the input. Yeah, so we'll make it a float. Because it could be, 375, something like that. We don't really care for this one. That'll be fine. Okay. Cool. All right. We'll float. All right. So we're good with that. Now what are we going to do? Okay. So we've got our value. What's next? So what do we want? We want to determine how much of a discount they get. So we're going to have to figure out their coupon percentage, right? So how are we going to figure out what their coupon percentage is? Well, we know because they gave that to us, right? So there's no question about how much they spent. Question.
Do we want to run it through a nested if statements to figure out what percentage we're going to get?
Don't know. It seems like it'd be an interesting thing to test out. So what would be the very first statement in that nested if statement?
To test if it's between 10 or less than 10 for no coupon, and then to go from 10 to 60. And so
that.
on.
All right. So it would be if cost of your groceries is if cost is less than groceries, then do nothing, right? Or your coupon is your percentage is 0, right? Effectively, is that correct? Cool. Now what?
Then we would go from to check if it was between 10 or 60.
Okay, so it has to be greater than 10, right? But it has to be,
No, it has to be equal to 10.
that's a good point. You're absolutely correct. So it has to be equal to 10, but,
Less than 60.
actually I think it has to be exactly 60. The
Yeah.
reason is because this says more than
Oh.
60. So this is from 10 to 60, so it's inclusive of 60. Okay, and if that's true, then what?
Then your coupon percentage is 8%.
Then,
Yes. So then what do we do after that?
Oh, then we go through another if statement to check if it's more than 60 through 150.
Right, and that's 150 is inclusive, right? Okay. And then if that's true, what do we do?
Then we give them a 10% coupon.
Fantastic. And what do we do after that?
Oh, do we check if it's more than 150 or between that to 210?
Okay.
And if it is, we might just give them a 12% coupon.
Fantastic. Okay, I'm getting sort of bored with this, but let's try it one more time.
Well, definitely if they want to spend more than $200, we're going to give them that 14% coupon.
Fantastic. Then once we know what coupon they get, can we calculate how much they got, right? And we can also tell them the percentage, right? All right. Now what's interesting is I approached this from the other way around. So you started at 0, or actually at 10, and I started up at 210. Now who was correct, you or me? No, I'm the professor, so of course I'm correct. The answer is you can do it either way, right? And once again, I want to stress that. We're talking about software development here, right? There's no right way. There is no wrong way. And I would argue that with your toolbox of Python statements, you've effectively been given a bunch of tubes of paint and brushes, and we all have the same canvas, right? Are we all going to create the same picture? Absolutely not. We're all going to create completely different pictures. But are they all pictures? And in theory, all of our programs, when they receive one set of input, should all produce the same set of output, correct? The art in between may be different, but the inputs and the outputs will be the same. Question?
The problem with this approach is we don't know how to do and statements in, like and or stuff like that in Python yet.
Why did we need an and in here?
Well, he was checking between this and this,
That's a good point.
which means you have to have two operands.
Of course, I don't know how to do it either, right? So in theory, mine should be able to be flipped to his, right? So you're right, that's a good point. So let's take a look at what's going on here. Cost of groceries equals float input. So we had talked about this a little bit, right? No big deal whatsoever. We're just taking two different actions and we're combining them, right? So I'm turning float because I'm getting an input of a string, right? So enter the cost of your groceries. That string comes in. I magically transplant it into a float, and I put it in a variable called cost groceries. And I say if the cost of groceries is greater than 210, then the percentage coupon is 0.14. Look, it's our brand new friend, Mr. Elif. Or Mrs. Elif, depending on who you pronounce. If it's greater than 150, then the first cost, the coupon percentage is 0.12. Elif, if it's greater than 60, it's 0.1. Elif, if it's greater than or equal to 10, then it's 0.8. Else, it's nothing. 0. Then down here, it's print. You win a discount of this. Now what I have here is $, percent, 5.2F. What's that going to give you? 5.2F. Is it going to print out 5.2F? What's it going to print out? Oh, float. Okay, that's probably what that F means. Good. 2 decimals, so point XX. Now we got that 5 thing.
There was 5 spaces.
So the window is 5 spaces big. Now what's going to be in that window? Already I can tell you 3 things that are going to be in that window. What 3 things are going to be in the window? The 5-character wide window that I have. I've already used up some of those positions. What did I use them up for? Now. A period. Exactly. That decimal point's got to be in that window, right? Poof. Okay, so that's one spot that's used up. What else is used up?
2 of those decimal places.
Exactly. All right, so the decimal point and 2 of those spots have used up how many spaces?
3.
Gotcha. So how many do I have left? 2. Exactly. So I can handle numbers up to like 99, basically. Hey, by the way, what happens if I spent like $105 on my grocery? What's going to happen when I do this print statement? It's going to make it bigger, right? It's just going to say, forget your silly formatting. Yeah, it doesn't matter. It's just going to blow out through the window, right? Python says, hey, I will try, and I will write justify, and all that sort of fancy stuff, but if you give me numbers too big, I'm just going to print the damn number, right? I think it will have 2 decimal points on it and stuff like that, but it's going to just blow away the rest of the window. Gotcha. I apologize, because this is getting cut off a little bit, but it's cost of groceries, and also the percentage was there. Something that I discovered about Python that I'd like to share with you. It's really, really hard to print a percent sign. Okay, and the reason it's hard to print a percent sign is because, remember, in Python, it's using percent as an indicator in this formatted string that there's some fancy stuff going on afterwards, right? So if you want to actually legitimately print a percent sign, Python's going to get confused, right? It's going to go like, well, what's up with this? So I tried a variety of different things, including the escape character before. That didn't seem to work. Tried printing a character, ASCII character, that didn't work. It turns out what the correct answer is, you want to print a percent sign when you're doing your fancy formatted strings, percent. You do percent, and Python goes, oh, you mean to print a percent sign, not a problem. All right. So our example, how much do they spend? 14. Cool. So we do 14, what do we get? You get a discount coupon of $1.12, and you get 8% of your purchase. We run it again. Make sure that compound thing works. How much do we spend at the store?
700.
Well,
Nice.
we were hungry. So we're going to 98.
Exactly.
And is 14 the maximum discount percent that we can get?
Yeah.
Cool. It seems to be working correctly. Would you agree with me? So our little Elif thing is there. You got a new tool in the toolbox. That is so cool. All right. So what's in your toolbox now? You got the print. You got the math. You got the strings. You got the IO. You got the if and out, and you got the Elif, and you got homework number 1, right? So this is everything that you need to construct a beautiful, wonderful, easy for me to read version of homework number 1. Homework number 1, what do you have to do? You have to turn in a printed copy of your code. You have to turn in, on paper, output from 3 separate runs. And I've given you the data, so you should have no problems with that whatsoever. But I'm looking for the actual real paper. There are some people who got confused last time about what it means to print something out. So I want to remind you, that's physical paper that you turn in. Got it? Don't give me your tablet. I don't need your tablet. Don't give me your laptop. I don't want your laptop. I want physical paper from you. If you'd like to put a little staple in the upper left-hand corner to keep all the separate sheets together, that'd be fine too. We've got no problem with that one. All right. So what did we cover today? We did hand tracing. So when your program doesn't work, which it won't, you now have a powerful tool to figure out what the heck's going on in that program. We did nested branches, and we introduced a brand new member into your toolbox, the Elif. How cool is that? What are we going to do next time? Looping. Wow. That's a whole new world. So that should be a lot of fun when we do it. Fantastic. We're done. We're finished. You're out of here. I will see you again.